Okay, so some of you guys have had some questions about one of the homework problems. It's asking you to find the how far a person traveled, find their displacement. So if you're looking for the distance that they traveled, then all you would have to do is add up the lengths of the 3 legs of their trip. But displacement is actually the difference between the start of the trip and the end of the trip as a straight line. So if you imagine flying from one spot to another in a helicopter, that's what they're after. And so you have to look at it from the vector piece. So you have to find all the horizontal ones or the x direction vectors and all the y direction vectors and treat them separately. So in the problem that you have, and I drew it out for you, you have 2 vectors that have a y component, and that's all of the first vector, the first part of their trip, and that's going downward. And then you have a little component of the third part of the trip when they turn the corner for the second time at that angle. So what you're going to end up with is some vector that's going to be whatever the length of 3y is minus whatever the length of that first one, and that's going to give you your total y. If I could only spell that right. And you're going to do something similar for the x, but it's a little bit more straightforward. You have the length of the second part of the trip plus whatever that component is. And that'll give you both the total x and the total y components for the displacement. And so you're going to sum each one, and then you're going to put them together using the Pythagorean theorem, and you'll find the magnitude of the displacement. So that's going to give you how far they actually traveled, the difference between the start and the end. And then the next one is, you can answer this so many different ways, and apparently this homework wants it in a particular way, so they want to know what the direction is. And so you have your x and your y that you found before, so it's got the piece that heads off this way, and then it goes down, and then our displacement is here. And so you're looking for what is that angle. And you want to look at a compass where you have north, south, east, and west labeled. And in this case, what they're looking for is, when you think about where it is, it's going to be drawn off like that. And I think it's something less than 3 if the numbers vary for everybody. It's about 3 degrees, and you'll use inverse tangent. So remember that the tangent of your angle is equal to the opposite side over the adjacent side, and that's how you get from your triangle to your angle. And then once you have your angle, it's going to be some amount, and it's going to be counterclockwise. So that's the abbreviation for counterclockwise. If it had been, let's say, over here, you might want to measure that angle, and you would call that clockwise. You could also call this, and the homework probably won't accept this, but you could also call that first angle south of east, or just southeast. And so that's a bunch of different ways to name things. I know that's not terribly specific. Obviously, one way would be best. But if you get stuck on things like that, let me know, because it really isn't about the physics. It's more about what the homework is asking, very, very specifically about nomenclature. So happy to help out. Bye-bye.